Hello, everybody. Thank you for being here. My name is Shubha Rao. I'm a product manager in Amazon. And I'm here to speak today about our newly launched service, AWS App Mesh. So what is App Mesh? App Mesh, in short, is a service mesh to help you get more visibility and control into the communication between your microservices. And today, I'm going to speak a lot more about why microservices, why service mesh proxy, why service mesh control plane, and why we built App Mesh. And then I'll get into a little bit of how do you represent your app, what features do we have now, and what's coming next. So to start with, if we have to think about a real-world analogy here, and think about really popular chefs and their boutique restaurants, there is a lot of process that goes into coming up with a new recipe, as well as to make sure that every single plate of food that goes out to the customer is perfect to the same extent that they would come back for more and they would really give it the greatest reviews. But that process is very similar to how you would have built a monolith application. It's easy and simple. There's one person who really knows it all, who has spent a lot of time in tuning and refining it, but it doesn't really scale very well if you want to roll it out to become a countrywide or worldwide franchisee. So if you want to really go big and have multiple people be able to replicate the same dish, replicate it in a way that feels the closest to the original, then you have to come up with cookbooks and recipes and guidelines to really look for specific things, and also teach people to be able to do it very easily without having to put in a lot of innovation or new thought into how it really is done. So the analogy is like monoliths and microservices. Like I said, monolith, there is slow, gradual improvement in the monolith. You tune it over time, you make it good, you make it better. It's simple and nice, but it's not often scalable, like how you would have to think about rolling out bigger franchisee chains. You would have to think about how do you replicate the same processes that you have learned in building your applications today and make it repeatable so that everybody on your team and every service follows it consistently, and thereby making it a well-functioning system that works together and serves your customers in the best manner that it could potentially do. So I'm pretty sure this is something that you all have thought about, you've heard about before. You're breaking down your monoliths, which are potentially managed by one single team today, to be handled, to be built as multiple services. And these have different developers, different teams, different operational guidelines, different requirements. And so there are a lot of people in the process. There are a lot of things that have to go right to really have it all come together very well. And over time, the services evolve. The services become tuned to doing one specific thing like it is supposed to, and they get divergent in the sense that they could be using different programming languages. They could be optimized to run on different managed services. They could be interacting with different sets of dependencies. And still, there are multiple teams who really have to bring it all together and make it work well. So over time, you may have to invest, or some companies do invest into having a separate infrastructure team, which actually does this type of coordination and offload some of the tasks that could be common across all these services. So what you see here is a microservice which has several teams, several programming languages, which are all interacting with each other. So when you think about how these evolve, you would have very different pace, potentially, of when you start with VMs. Do you containerize it? Do you make it Lambda functions? Do you make it managed services? And all these add to the complexity in the sense that there are you cannot really follow a single recipe anymore, and you cannot make it one consistent guideline that everybody can follow in the same manner anymore. And that brings multiple needs for making sure that every team does know and follow the best practices and the guidelines that are recommended. And this includes everything from getting visibility into every part of your application stack, getting a consistent operational guideline around how you deploy, upgrade, monitor, and even identify or fix errors, It could be multiple teams who are doing their own DevOps. It could be centralized ops. Each company wants to be in a different organizational structure, and you still want to bring in all the CI/CD mechanisms. You want to automate it as much as possible and ensure that there is highest security and compliance that is met by all of these individual teams. So in short, what do you need to make the microservices work well and work together is a consistent mechanism where you can observe, orient, and decide and act what exactly and how exactly do you handle them together. So that includes communication management, and that's visibility and control across all these services. It includes handling failure situations, isolation of failures, and also controls to give you automatic deployment capabilities to fix the issues if something goes wrong. So we saw about all the different things that microservices need. How do they all come together, and what are the options, and what do you do today? The most common approach that has been used until today is libraries and SDKs. But there is a lot of heavy lifting involved in making sure that each team has that and follows that. So at a very high level summary, SDKs involve a lot of maintenance. There is installation. You have to take care of migrations to keep track of the latest versions, deprecation workflows, upgrades, coordination between different teams that are required to maintain consistent versions. If not, there is actually a lot of issues that could arise just because of these inconsistencies, which affect the velocity with which you can roll out new applications, that affect the velocity of the overall pace at which each team can run and deploy code to actually bring in new features and capabilities. And over time, this gets really hard, which is the reason why service mesh proxies have become the new architecture pattern. So this is not any net new capability. It is bringing out the same features that is needed for each service and across each services, and bringing that out as a sidecar proxy that runs along with your application instead of being a part of your application itself. So overall, the proxy does provide application the capabilities such as logging, metrics, tracing. It runs along with the application, often in a containerized environment as a part of the same task or pod as a sidecar. And the biggest benefit it brings is that it minimizes the application code required in each service. It simplifies it to be a template that you don't have to teach every new team to learn and use in a similar manner. And it actually brings in the decoupling that is needed with your business logic and your operational logic or the management logic, so that you can configure and handle them separately, simplifying to a large extent what your application code looks like. And this minimization of inconsistencies helps a lot in ensuring that each team can move faster and still do the same right things that you have learned as the good practices that every team should be following. So what we've spoken about until now is why do you need a service mesh proxy? At a very high level, it helps you migrate monoliths to microservices faster, better, and in a more efficient manner. And it provides you the operational controls that are required to separate out the application logic and the business logic with all the management and the infrastructure needs. And the benefit is that it can work the same way across teams, across languages, and across different workflows that each team has evolved to use. So I said I'm going to speak more about App Mesh today. App Mesh uses Envoy proxy. Envoy has evolved to be a very widely popular community project. It has been stable and proven in the community for a while. And just yesterday, it has been promoted to a graduated project status in the CNCF. So App Mesh relies on using Envoy proxy to provide all the mesh proxy capabilities that we just spoke about. So we already have an open source proxy. What is the hard part in using it with each service, and why do we need anything else at all is what I want to talk about next. And so the biggest way to handle the proxies today is to actually write your own logic to make sure that every proxy has a consistent view and can reliably get the latest configuration that it needs to handle the microservice communication. So we don't, without having to hard code any part in each proxy itself, the way you can provide it the configuration in a reliable, consistent manner requires a lot of work, especially when you have hundreds and thousands of proxies, that is hundreds and thousands of containerized microservices that are running and also potentially changing at the same time. So there is a lot of heavy lifting that's currently involved to make sure that all the intent that comes in from each development team or operations team is translated into what a service mesh proxy can understand and apply. And this intent has to be merged with the intent that is required to actually align with your latest changes in the environment. You may be doing new deployments, you may be upgrading your services, you may be scaling your existing services, or there could be something that's happening in either the network health or the microservice health. So you don't just need a system that understands the static APIs or the intent of the teams, you also need it to adapt to the dynamic changes that are happening in your environment. And that means that the proxy has to keep track of all these changes and apply it in a reliable manner. So it has to compute, store, and distribute it in a reliable manner to each and every microservice that wants to participate in the mesh and in the communication management. So what do we need here? At a very high level, the control plane helps you just get this logic or get a mechanism to reliably store and distribute the proxy configuration at scale. And you need it to not really be tied to the application or to the language. You want it to ideally work across several compute services that you use today, and also be tied to your existing systems, be it deployment mechanisms or visibility and monitoring tools. And the easier we can make it for you to use it is what is better. So we are looking for a way to make it simpler for you to not spend all the development time, effort, and management it takes to build the mesh control plane. So when we spoke to customers about what exactly would they need to really have this whole microservice migration go faster and better, we heard a couple of additional requirements, especially among our customers who are running services across clusters, across compute services. We wanted to build a system that meets the customer's needs in terms of scale, reliability, and also providing the same SLAs that you expect from an Amazon service with the partner integrations and with the Amazon tool integrations that you require to do it in a similar manner as much as possible. We did hear a lot of requests also about multiple container services, and we wanted to build something that meets all your needs in terms of not just relying on the open source and the community innovations, but also giving you the Amazon style of using it without having to put in a lot of effort yourself. And these are the motivations that led us to build our own app mesh, which essentially integrates with the existing deployment mechanisms, which we want to integrate with the existing deployment mechanisms we have, integrate with the container orchestration services we have, and also give you integrations with the open source tools and the partner tools and the community, and be as community friendly as possible. So what does the app mesh do? App mesh essentially configures each proxy that is running along with your microservices, and once it distributes the configuration, the actual traffic path between services happens just between the proxies that are involved with the services. There is no app mesh in the mix, in the sense that your application containers speak to the proxy on the egress side, and then they speak to the proxy on the destination service, and that speaks to the application containers. So as App Mesh is available as preview starting yesterday, you have the ability to plug in all the observability tools of your choice, to bring in all the traffic control capabilities that you would want to provide to your applications. We are working on a couple of features. We have the traffic routing controls available for you to start using right now. We are working on the traffic shaping features, the client-side retries, circuit breaks, et cetera. And we are working on a lot of the integrations that will make it easier for you to deploy, run, and manage applications on AWS. So it's available in 4 regions starting yesterday. We have a demo coming up later about integrations with Xray and Prometheus. We have a CloudWatch integration. We are working with Datadog to have that available as well. And between this preview launch and GA, we'll actually work on a lot more smoothening the process and heavy lifting to make it all seamless and smooth. So what capabilities can you use, and what capabilities does it really help you with right now? In terms of observability, along with getting all the logs, metrics, and stats into your preferred tools, you can also identify issues that may arise before things go completely wrong. So it gives you better control and visibility over error codes. It helps you isolate whether errors are in the service itself or whether it's in the network between the services, and helps you catch it when the system goes into a degraded state rather than after it goes into a failure mode. And it gives you the additional controls to not just handle it once, but also bring in newer versions of your services and granular controls that are required to roll out new deployments, in the sense that you could do path-based routing. You could start doing canary rollouts and deployments, in the sense that you can start testing out traffic and rolling it out to newer versions as in a gradual phased manner rather than all at once. So although you can do that level of control with the number of parts and the number of tasks that you deploy today, an app mesh helps you do that in a much more granular manner based on the HTTP headers or cookies or a lot more finer controls into what specific traffic do you want to route into your newer deployments before you actually are ready for it to go live and go prime time. What do we have? In preview, we have the APIs available. We have some examples available for you on GitHub. And we do have a couple of integrations, especially based on StatsD. We have HTTP path-based routing ready. We are working on a couple of console integration. We don't yet have a console. We are going to provide a good API, a good console experience for configuring and managing the mesh. And we are working on integrations with container services. And we also will be bringing in multiple capabilities post-GA. Going a little more into the integrations, today you can use App Mesh with DNS-based service discovery. We are working with AWS Cloud Map, which is another new service that we launched yesterday, which can give you service discovery across Amazon services. This will help bridge services that you have deployed across different container services and essentially extend your mesh to be available not just with ECS or EKS, but also across EC2 in the future. So how does this all work? I want to now switch gears to focus a little more about how do you represent your application in the app mesh, and how do you really bring in the different routing controls represented in the API so that you can do all the cool capabilities I just spoke about. Starting with, let's say you have a simple application where you have one service A interacting with a service B. So the first step is to actually create a mesh, in the sense that it's more of a logical boundary that holds the representation of each of your version service. So there is virtual nodes that represent specific version services, and each deployment or each service version is represented as a virtual node in the App Mesh APIs. So the virtual nodes themselves have multiple fields. Listeners are the ports that you expose from each service. These are the ports that you are having your services listen on. Then there is service discovery. This helps you provide input on how you want a specific service to be discovered. Essentially, how do you identify the set of endpoints that you want communicating with the other services that connect with this service. Today, it's a DNS name. And when we have AWS Cloud Map integrations, you can have name along with metadata, where metadata represents specific subsets of your services. The third field is backends. Backends represent the dependencies or the other services that this particular service relies on. So if your service A is speaking to B, backends would be B, whereas listener and service discovery is what A is exposing to the clients of A. And all this together represent the service A, which you would need to have one for each of your version service. So once you have services A and B represented as virtual nodes, you would how do you connect them together? For that, you need a virtual router. Virtual router is essentially a construct that helps you expose the backend service to all its clients. So the thing about the blue boxes here that you see, virtual routers, essentially map to a set of service names, where you're saying for each service B that you want to expose to a set of clients, the DNS names that you use or the service endpoints that you use for the service B is what you represent in a router. And then you get to have a lot of routes which represent exactly how this traffic has to be handled by each of the client that is connecting with the service. So for each service virtual router, you can have multiple routes. One of the sample routes that you see here just has a very basic prefix match, which says all traffic goes to node B. So this is actually creating the link between A and B, in the sense telling App Mesh to create configuration for service B that will be distributed to the proxies that are deployed with service A. So note that there is that computation of which clients need to be programmed with the config that is mapped to a particular server service is done by the proxies. It is done by App Mesh. You can have one or more routes, and once you have, if you want to represent a set of new service versions, then you actually create a new virtual node B, and then you can update the same router with having routes that represent the new version as well. So you have, here you see an example of how do you update the existing virtual router config from not just sending all traffic to the version B, but also send some part of it to version B prime. Again, we support weighted routes, so that will help you gradually roll out traffic to the version B prime. So how does this all come together? If A is speaking with B and B prime, then you have these virtual nodes, you have virtual routers, and then there is the mapping between the backends that you specify in A, which speaks about all the dependencies that the service A has, to the service names that you have in the virtual router to identify what specific config you need in which service. So note that this could also include not just routing, but also traffic shaping policies. So the way it works is that once you have the routing decision made at the client-side proxies, the traffic policies that apply to that communication is applied after the routing decision, so that if B has a different number of retries that it expects its clients to make compared to B prime, then only the traffic going to B will have that specific config, and the traffic that is going to B prime will be updated with the right traffic policies you specify for B prime. So overall, what is this helping you do? It's helping you have a delineation between the client services and the server services without actually having the intricacies of the versions and the rollouts exposed to each other. So, if I am the owner of service B, I could be deploying 5 versions per day, but all the clients that are connecting to me are still using the same DNS names, and they are still using the same endpoints to connect to, and I get to control what specific traffic policies need to be applied to all that communication. So essentially, you're templatizing the service owner's intent in terms of how other clients need to communicate to the service owner's service, and then making it reliably distributed, and App Mesh is reliably distributing it to each proxy that is deployed with the client services. So that my intent of how my service is exposed to all the clients are represented at the proxies that every client has, and this helps in keeping the clean delineation and the separation in terms of the ownership boundaries, as well as giving you consistent controls for multiple services that are participating in the same system. So because all these services are having the same Envoy proxy or similar versions of proxy, you get the same observability metrics, get the same traces, and you still have granular controls to shape the traffic in a manner that is appropriate for that service. What happens if the service B has multiple dependencies? You map them as backends of the service B. So what you see here is in that service B, as a part of the virtual node, you will be mapping that to the virtual nodes that represent C and D, to the virtual nodes that represent C and D. And how do you export all the observability data into the endpoints and the tools of your choice? There is a way to plug in the Envoy Bootstrap, again through the API, which helps you connect, pull all the metrics and logs and stats that are collected at the Envoy and publish it to the right endpoints. So with this, we'll switch over to a demo. Tony?
Until I touch the keyboard, right? All right, thank you. So yeah, that was exciting. What I'm going to show briefly, and even less time now than before, is that I'm going to give a little demo to show working with the mesh and show what that looks like. There is a project that we will be open sourcing here shortly. Look for this next few days, next week. It's based on the canonical Docker voting app. We made a few modifications to it so that we could show off service mesh, app mesh. And all we're going to show off right now today is I'm going to take the client, we're going to cast some votes, and then we're going to get some results back. We'll see results coming back through 2 different versions of our reports API. So in terms of the mechanics of making all of this work, first of all, we've got a typical CloudFormation stack. It's got all of our services in it right now. And really the only thing I want to call out in here is pretty standard stuff. But when you take a look at our tasks for each given task, so seems like my audio is a little weird. For each one of the nodes in our mesh, so each of these services are going to be running. They're all going to be instrumented, and each task definition, in addition to the service itself, you'll see here we're including Envoy. So Envoy is going to run as a sidecar with your task, or if it's this for Kubernetes, with your pod. After we deploy that, you got a running application. You should have logs and all that kind of stuff. And then the next part of this is actually configuring AWS App Mesh to work with this application. So again, this application is a microservice application. It's got a number of services. This is a pretty simple topology here. We deployed it with CloudFormation, and then we had to configure it to participate in the mesh. And what that looks like, for example, for each one of the nodes, again, going back to this picture right here. So for vote, and for the votes API, the reports API, and the backend, we've got these definitions. We define the virtual nodes. I'll just pick web for right now, the front end. We define those listeners that she was talking about, and we've defined that we're going to communicate from that node to 2 different backends, so to the votes and reports API. And for each one of those, they're going to, let's see, votes will talk to a backend, it'll talk to the database, and same with reports. It's very simple. The configurations here are minimal and simplistic, and the only thing that we're going to do that's going to be really interesting for this demo is we are going to do a little bit of simulated A/B testing here, where we're going to shift traffic 50% between our report service V1 and report service V2. Nothing super exciting and dramatic as far as the changes between those two services, and I'll show that in a minute, but that's it. So each one of these routes are going to be associated with a virtual router, and those definitions all live in here. Very simple as far as defining that. My point here is that the configuration is simple. To participate in the mesh, there's not that much you have to define here, other than to make it very clear what these relationships are going to be between the nodes. I do want to draw attention to the fact that when we are defining here service names, they're the logical service names that your services will use to communicate with each other back end. Now, I've already deployed the app, and I've already actually applied these configurations. So I'm good to go. I can vote. I don't know, what is it, cats or dogs? I'm going to go with cats. And I guarantee that cats are going to be winning. So results. Cheated. I've already got a number of votes here. All right, so what we can see here is that V2 replied. I'm going to run this a few times. And approximately 50% of the times, the original V1 response comes back. All right, so that's working. All right, so the next thing that I want to point out here is that we have full visibility into what's going on inside of our mesh. Oh, is this not? Right. Let me unplug and replug. Sorry. Wow. Well, okay. Cats won. But the point was, there was a distribution here. About 50% of these responses are. Let me do this again. Yes. Show the V1 simple response and the V2 more complicated response. And moving on quickly now, what I want to point out is I'm in the Xray Console, and we've got visibility into our application topology and the routes that were traversed. So what's happening is that for every segment here in our mesh, all the communication routes, ingresses go through the app and go back each one of the app nodes and egress through an Envoy proxy. And for any of these, we can take a look and we can investigate what's going on. If we have any broken links in our mesh, if one of our services isn't working or responding, we can take a look at latencies and all that good stuff. One cool thing to show is that Envoy itself imposes minimal overhead as far as what's going on with the communication between these routes. The other thing I want to mention is that we even have an integration with Prometheus and Grafana, another very popular open source package for metrics. And we can take a look at what's going inside of the mesh here, take a look at the number of successful connections, calls, requests, responses, that kind of stuff. And I guess what I want to also mention is that we've got integrations as well with CloudWatch, and you can expect all your other types of integrations to work because this is part of the platform. So some of the stuff that involves open source integration, that stuff's been done. These examples will get published. There'll be a deep dive into the work that goes as far as what you can do, how do you change your configurations, how you integrate that into the rest of your dashboards. So to recap, pretty simple, pretty straightforward. Simple configurations that need to get applied to make these participate in the mesh. And then you get all the benefits of being in the mesh, all the benefits that Shubha had outlined earlier. So that's it for the demo. Thank you. I'll get you back to your...
Yep. We have a lot of content out there already. You can see some examples in our GitHub repository. This is preview. We have just started. Do let us know what you think, and do let us know about the additional use cases you would like us to think about, as well as if you see any issues or if you want to have a discussion with the team. And with that, I just want to say thank you for being here. We have the team here as well, so we can take some questions. Thanks. There's a mic on the side. Mic would be better so that the others can hear. Kiran.
I had a question. Could you go over again how, if you're not inside the mesh network, how you connect to something inside of it?
Give me a minute. Kiran, James, Tony, to just answer questions if needed. OK, sorry, go ahead.
For a migration, as we're migrating onto App Mesh, how do you connect to stuff that has not yet been integrated into it yet? Like, say we have stuff on-prem in a data center. Is it possible to then, how would I then communicate with something inside of this mesh?
So when we integrate with AWS Cloud Map, that will give you a way to represent your services across multiple AWS services. So essentially, you'll get a service and name and an endpoint that can map to any AWS service. That's how much we have planned for GA. If you have other on-prem use cases, we would like to discuss that and plan for it after that.
Thank you.
Hi, very quick. Istio, because seems there's a lot overlapping with this, so I was curious to know if this is your take on Istio or you plan to diverge and do something completely different?
So when we looked at what our customers required, the most common theme was to actually have it based on Envoy open source proxy. So that's what both Istio and App Mesh are using as the data plane component, which is where most of these capabilities come from and where most of this magic happens. So we'll be contributing back to Envoy proxy pretty significantly in the coming weeks and months, and Istio will benefit from that as well. You can already run and use Istio with EKS and with any Kubernetes on AWS. So these are just different approaches to reaching the same end goals. And this is the Amazon built and run managed service model, which would work for many of the customer use cases we've heard until now. So these are choices, and feel free to use what works best for you.
Thank you.
Hi, two quick questions. First one being, what OSI layer does the proxy operate on? And the second one being, can we see egress to things like AWS Aurora, which is layer 4?
The proxy is layer 7 proxy, so it understands the layer 7 protocols. Starting with HTTP, you can directly route on the HTTP headers and cookies. We're planning to add all the gRPC and other routing protocol support.
And to add to that, so Envoy actually is a layer 3 for proxy.
Okay.
And the way it operates is having additional filters, and HTTP is one of those filters. So whenever a new connection comes, there are filters which start to process the bytes. So you can use it for anything which is TCP. UDP is not supported yet.
OK, fantastic. Thank you.
Which protocol will be enabled by default? So I saw the demo only uses HTTP, but Istio supports like a lot of them, HTTP2, WebSockets.
Today, it supports only HTTP 1 and 2. We will be soon adding gRPC and other WebSockets, all the capabilities which Envoy provides. We're just getting it out. And so our goal right now is to make sure that the distribution of configuration and the latencies at scale are appropriate, but adding features as we just go and keep on adding them. So.
Right, and also Envoy supports like injecting your custom HTTP headers and base routing on these headers. Will it be also available eventually?
So custom headers, when you inject, so you're mostly adding some filters. Is that so? Custom filters are not yet supported.
Okay.
We will soon enable configuration, which will allow for configuring existing Envoy filters. If you bring your own custom filters, we have an open issue in the examples. We'll open a proposal, and we should discuss on that.
Okay, thank you.
Hi. Will I be able to use this for service-to-service authorization at all?
Sorry, can you repeat it again?
Can I use the the App Mesh for service-to-service authorization?
Yes, so App Mesh by itself doesn't provide service discovery. So it relies on, say, for example, DNS or Cloud Map for service discovery. So if you bring, say, for example, Zookeeper or something else built on some etcd as a service discovery, so the two options are you have to build the EDS, which is the Envoy Service Discovery Protocol shim. So a shim on top of that. We will be writing a shim for Cloud Map, which is HTTP API. So we will be writing a gRPC endpoint for that. But we'll provide a way to plug in your own custom EDS endpoint if that is what required.
Thank you.
Hi, how do you see this product integrating with a pipeline, a continuous integration, continuous deployment pipeline?
Yes, so
Go ahead.
Okay. So the way we model it is, as you might have noticed, so virtual nodes is the core concept. The node is an endpoint provided by a set of, so is a name provided to a set of endpoints. So you can model in the pipeline when you deploy a new version, you essentially are going to create a new virtual node in the mesh as part of the pipeline hook. And then it's up to you to configure the route appropriate for that node. So you can say, for example, a blue-green deployment, you can say move a certain percentage or maybe 100% to the new version, test it for a while, and if it doesn't work, point the route back to the old one. So each of these versions which you're deploying through your pipeline will be represented as a node. They may have thousands of tasks behind them, but they are collectively are pointed by a node. And all the envoys which are packaged, so you need to package Envoy along with your application, and that Envoy is injected with this node name, and when it connects, it is going to get the configuration corresponding to that. So, so the way, in the pipeline, whenever you deploy a new version, it corresponds to a virtual node in the mesh.
Okay, thank you.
Hi, do you have any plans to implement like a front proxy pattern? So,
yes, so if you're talking about ingress style, so right now we are heavily relying on ALB and API gateway to provide it. We have heard some customers ask for, because of some protocols not yet supported in ALB, and Envoy also provides more metrics and stuff. So there is nothing stopping you from actually modeling the node as if like an ingress.
Yep.
So at the end, it is just a node which receives some routes.
Yep.
The only difference being that ingress has some additional capabilities rather than just a sidecar.
Yep.
So the scale may be different. For example, the number of routes you may want to define on the ingress may be much higher than a sidecar. So we haven't gone through that. So for a normal ingress, it should still work. But if you want to replace like the entire fleet with thousands of services like Amazon would do, that would require a special design and testing. So we are not testing for that use case.
Thanks.
I'm just curious about the roadmap for a planned use for like EC2, Firecracker, or Lambda. So
yes. So again, wherever you can run Envoy, it should be able to connect and get it. Right now, the challenge is how do you get Envoy along with the application? With tasks and pods like ECS and EKS, you have orchestrators so that you can package sidecar. But EC2, if you bake it into the AMI, or if you have a Chef, Ansible, or somehow you get Envoy in there, App Mesh doesn't care where the Envoy is coming from, as long as it has an IAM role to connect to the App Mesh and the right permissions.
Okay, and then we probably, I assume, set up the right DNS records or for the APIs that it's calling to the App Mesh.
Yes,
okay.
exactly. And in future, we will look at much more tighter integration with EC2, say, for example, auto-scaling, so that we can maybe automatically add or provide a template so that Envoy comes in there. And Firecracker by itself directly you can't consume. You will be consuming through Fargate or Lambda. So Lambda is something interesting to look at, how it fits in there, but Fargate will have a support.
Cool. Thank you.
How it could complement compared to the cloud map?
Yes. So cloud map is a way to define, so you point a resource name, and that resource name may resolve to multiple resources which are defined on AWS. So one way to see that is you can have a resource name which is a service name, and which may resolve to endpoints, which is IP addresses, which are also sort of resources in AWS. So one way to think is cloud map is a service discovery, but you can also think that it's much more than service discovery. So what App Mesh does is it uses cloud map like a service discovery. And so what it does is it takes the registry information, which is defined in the cloud map. It takes that, converts it into Envoy and Envoy configuration, which Envoy understands, and relays it down.
It basically sits on top of.
Yes. So it uses cloud maps data as a source of truth for the endpoints and relays it to Envoy.
So, I mean, again, one more question is how compared to the K8's orchestration and also the Eureka service, right?
Yep.
Is it easy to migrate if you want to move on, or?
Yeah, so we will have samples soon, which works with EKS. It's not just EKS, it's any Kubernetes. EKS may have easy to install controllers to deal with App Mesh integrations, but you can use them to integrate with any Kubernetes. So yes, so it will play well with orchestration. Kubernetes does well with deploying your applications. App Mesh and any service mesh solution works well with connecting those applications. So they play complementary to each other rather than like one replacing any other.
Thank you so much.
Have you looked into GraphQL schema stitching at all with remote delegation?
Not yet. That's an interesting idea. Right now, we are heads down and getting the basic stuff. Sure. But certainly, we would love to get that feedback on the examples. But that's a great addition to Envoy itself and as a filter.
Great. Thank you.
Yeah.
Awesome. Thank you very much.
Thank you, guys.